Swayam Prabha. Digital India. Educated India.
We are studying the conventional abrasive processes, wherein we are going to study about the new process in this class. In the conventional abrasive processes, we are studying about various processes such as grinding, lapping, honing, super finishing, so on. So these are some of the conventional finishing processes, wherein till now we have completed up to grinding process and honing process and other things. In this particular class, we are going to study about the lapping process. Okay, so we mostly concentrate on the lapping process in this particular class. As you know, the super finishing, lapping and honing, these are all the costliest processes among the conventional abrasive finishing processes, because if you see the cost, manufacturing cost, it is high compared to grinding and turning process, which is a single point cutting tool, which is turning process, as well as a multi point cutting tool, the grinding process. And the roughness that you can achieve, that means the finish you can achieve is very low. That means the roughness value is low, means the surface finish is better. That is what I want to say. If the surface finish requirements are so high, or that means that the surface requirements are good. I mean to say the surface finish is good, that means surface roughness is low, then the price of that particular product will suits up. That means that exponentially it will increase in some cases. Some cases it may be double, some cases it may be triple or something, because your aesthetic appeal will be very, very good. Like stainless steel products, if you take with a lapping process, it will shine. You can see your image. That means that you can get the mirror surface or roughness also. So you can even get with the lapping process the super finished surfaces. That is what. Now in this particular class, we are going to study about the only lapping, and in upcoming class we will study the super finishing and other studies, which are in the umbrella of high cost production systems. I can say these are all high cost production processes, and these processes are the final processes as per the conventional manufacturing of the component is concerned. Overview of the presentation, we will see about introduction to the lapping process, lapping terminologies, two body and three body abrasion in lapping process, when the two body will occur, when you can call it as a three body abrasion, and all those things in the three body in the lapping process, various types of lapping process, main components of lapping process, advantages of lapping process and applications. Most important thing is that if there is no application, there is no need to study. I cannot say that there is no need to study, but the importance will go down. Okay. So if at all a manufacturing engineering has to be studied, you should choose what are the applications of this one. If the applications are good, then your manufacturing has certain value. Okay. Coming to the lapping process. So the lapping process, if you see the draft, lapping process draft from the museum in Munich in Germany. So this is how the ancient people might be using for the lapping purposes. So you can see here, this is a thread which are pulled on both sides with a certain velocity v, and the load is applied, which is in this condition it is F with respect to the two loads. This is the load 1, load 2. These are the load that are tied to a thread and kept on the wood. Okay. So, there are some constructions that they have done with the fixing the bases, and it is held. This particular portion, this will be rolled, and the surface whichever you want to polish, this is the polished surface. Polishing surface they want to do, and this is the lap in this particular. Okay. So, these are held tightly here, and with the threads on both sides, people will be pulling like in that means that it will be rotational effect will be there, and there will be a polishing of the ground or something. This may be using for some purposes. In ancient people may be using for their making of their weapons and sharpness weapons or some other household items, or many things they may be using, and this is the one of the schematics how a lapping process can be developed. This is the old one, and you can see the latest developments how they have evolved across the globe with respect to time, that you are going to see in this particular class. So, the lapping process, if you see, the lapping is a gentle and fine operation commonly used with low speed and low pressure to generate the ultra fine finishes. That means that the application of load, in the previous slide you have seen two loads are there. So, load 1, load 2, the application of load will be very, very small. That means that as per the requirement. Basically, the lapping process is used for finishing processes. This lapping, if you see here, this is the finishing process, conventional finishing process. Okay. If it is a conventional finishing process, means my requirement is to get the better surface finish. In that circumstances, obviously you go for low speed and low pressure. Pressure means you apply the normal load. Okay. These are all small. So, if the small, then what will happen? The stress exerted by the lap on the workpiece will be very less, and the indentation will be very less. So, the fine finishing will take place by shearing the topmost peaks of the surface, and extreme flatness is required or roundness. In case of generating the flat surface, you need extreme flat surfaces. If at all you are going to do for cylindrical workpieces or other workpieces, you can go for extreme roundness, and critically close tolerances you have to use. Okay. So, during the lapping, material removal takes place by lapping abrasive particles that are dispersed in a water or oil liquid. Basically, water and oil, these two are carrier liquids, medium you can say. Okay. These are the carrier mediums. That's this carrier medium has its own functions. It will act as a lubricant. It carries abrasive particles from location to location in the finishing region. Okay. So, if you see the lapping process, how the schematic of the lapping works here. This is the workpiece. As you can see, this is the workpiece, and this is the lap. Lap is nothing but it is a pad, which is a porous pad or a fibrous pad. Many people uses polymer based or fiber based, like cloth also people will use, and these will have abrasive particles. These are the abrasive particles which are embedded. Just these are all mixed with the carrier medium. Okay. This is abrasive particles. You can say this is abrasive particles in red, so you cannot see here. And these are impregnated with the carrier medium. Okay. So, carrier medium you can see here, This is dot dot whatever you are seeing the carrier medium. If you use for certain time, you apply certain load. Now you have to apply certain load. And if you do the lapping process, what will happen? The shear, it will shears the peaks what are there, and the surface will generate like this. Okay. So, the peaks will disappear or sheared off, and you will get a good surface, that is the finished surface. This is how the mechanism of lapping works, and in deep we can see in the upcoming slides. Introduction to the lapping process. Lapping is basically an abrasive process. You have seen there are abrasives, there are carrier medium, there are some other additives that people will add, which loose abrasive is a function of cutting points, finding the momentary support from the laps. Laps is a pad. I said lap is a pad, which can be a polymer pad, which can be a fibrous, that is a cloth or something. This will help the abrasive particles as well as the carrier medium to spread across and to do the finishing process. The lapping involves the cutting, shearing action of the loose abrasive particles. As you know, the lapping process uses loose abrasive particles. There are two varieties of abrasives commonly available. One is bonded abrasives and another one is unbonded abrasives. Loosely bonded abrasives means these are unbonded abrasives where there is no bonding. Bonded abrasives you can see in the grinding operation or a honing operation where your abrasives are bonded with the bonding material. Like you have seen the specification of grinding wheel where these abrasive particles are bonded with the bonded material in a specific pattern on a grinding wheel. But here these are fully having the freedom, they can go everywhere, depend on their motion with respect to the pad in the lapping process. And fine grinding of abrasive particles embedded on the lap plate. Normally these particles will embed on the plate. Some of them are free, some of them are bonded partially to the pad, and they will do the finishing operation. The material removal in general, normally it ranges from 0.003 to 0.03 mm, but it reaches to 0.08 to 0.1 mm in certain cases. Whenever you are going to use core structure of abrasive particles, you can achieve the better material removal rate. But whenever your application is for finishing applications, you have to always go for 0.003 to 0.03 for finishing applications. This is for finishing applications. This is for material removal applications. Okay. This is how you can remove the material. For this material removal, what you have to do is you have to use high load. Here what you have to use, load should be high and abrasives should be coarse. Okay. That means that size of the big size particles. Okay. In that circumstances, you will get material removal very high. Here in this condition, load should be low and abrasive particles should be fine or super fine. These are the two variants. If you are going for fine and super fine abrasive particles, where finishing is the achieved goal, and if you are going for a coarse and high loads, your material removal. If at all your condition is for material removal, if the condition is material removal, in that circumstances, you need not to go for only the lapping process, you can go for a grinding process. Normally people prefer for finishing application, that is why this is preferred for the finishing applications. The characteristics of the lapping, it uses loose abrasives between lap and the workpiece, as you have seen in the previous slide. Lap and workpiece are not positively driven, but they are guided in contact with each other, and the relative motion between the lap and the workpiece should be changed continuously to the path of the abrasive grains of the lap is not repeated. Normally, the path may not be repeated. So, because the abrasive particles path is completely random, because abrasive particles are having full freedom to move, because assume that I have a workpiece and that I have a lap and abrasive particles are embedded with some oil. So, if your oil is not going to bond with respect to abrasive particles, so your abrasive particles can have free motion. So, there is no repetition of the paths in this condition. Okay. So, lapping parameters, normally lap wheel or lap plate, which type of plate you are going to use, whether you are going to use ceramic plate or ductile plate or other thing. Lapping medium, whether you are going to use oils, whether you are going to water, whether you are going to use the combination of water and oil, whether you are going to use emulsions, what are the things that you are, and lapping abrasive particles, which type of abrasive particle you are using, what is the size of the abrasive particle, and other things, amount of the abrasive particles that you are using. These are the very critical things for the lapping process. Okay. So, the lapping plate can be a hard plate or it can be soft plate or something. If you see the schematic, this is the lapping process where the ground glass, if at all you want to use, or these are the abrasive particles, and where you have a medium of water here, and the 5 microns diameter alumina powder particles are used for this particular thing, where you can use for the finishing applications. There are few varieties of lapping processes there, among which one of the most important for the developing nations like India is hand lapping. Okay. Many of the small scale industries will completely depend on hand lapping process. This is where you just take the workpiece, this can be workpiece or the upper one can be workpiece, and you just apply the paste, that is normal, this is the abrasive paste. And you take some other counterpart and you are going to apply the load with respect to your fingers on this one, and you do the lapping process. So, you will do the finishing process in this way. Other one is machine lapping. So, but in the hand lapping, the basic problem is it is a time consuming. At the same time, the operators, different operators put different pressures on the workpiece. So, they need to have lot of control over their fingers and other things. So, it is easy. For that purpose, people gone for machine lapping, where you can go for the hydraulic type of load or pneumatic type of loads and other things. The machine lapping is done either with abrasive powder or bonded abrasive wheels also people can do. So, you can see here, these are the workpieces are placed and the machine will apply certain pressure, the fluid will be continuously flowing and the abrasive fluid will be continuously flowing and the finishing will take place. In this one, this can be a mass production or a batch production, but normally the hand lapping or a manually whatever people will do, this will be done for final finishing operation. For complex surfaces and other things. Okay. As you can see here, lapping tool is rotated or oscillated, moved across the surface. This is the rough surface. This is the rough surface on which your abrasive particles are loaded, and lap will going to apply certain pressure on it and it will be rotated or oscillated, so that you will achieve the final surface finish. So, all the peaks are gone here and you are going to get a proper surface after finishing. Okay. This holds good for many applications. Even grinding also works in the similar lines. Only thing, the difference between grinding and honing and as well as other finishing process is the how much better surface finish that process is going to achieve is the only target. Lapping tool or a wheel. Normally lapping tool is a flat disc which is plate is made up of cast iron, aluminum alloy, copper, brass, or many other material like ceramic also people are going to use, and other type of workpiece materials, other type of disc materials people will use. Abrasive materials are carried by the medium agent. Normally it can be a grease, oil or water. Higher viscosity means higher abrasion, because if you are going to use the oils or grease, if you are going to use the grease, then the material removal rate will be very high. You can see here the surface lapping. Or you can see here cylindrical lapping where the cylindrical workpieces are there, or you can go for the flat surface finishing also in this one. So, lap position and pressure control, normally it will apply pressure as well as you have a rotational motion, and the fluid will be circulated across the surface to be finished, and the finishing action will take place. Here the workpieces are circular workpieces. Here it can be a rectangular workpieces, or people can go for a cylindrical type of workpieces also. The cylindrical lapping is also one of the process that you come across in this class. So, in this lapping process, the mechanism goes by two body abrasion as well as three body abrasion. As I said, this is the workpiece which is shown already, the load is applied, and when it called as a two body abrasion, so this is your lap or lapping plate. This is my lapping plate, I can say, and this is my workpiece. In between I have abrasive particles as well as carrier medium. This red dots whatever you are seeing, you assume that this is the oil that I am going to use as a carrier medium. In these circumstances, there are two options or there are two possibilities. One is the two body abrasion. Let me explain two body abrasion. This is my workpiece, this is my pad. If my abrasive particles are fixed, that is embedded already, this is the abrasive particle which is embedded already inside the lapping pad, this motion, the motion of the abrasive particles will be restricted. These particles are fixed, okay, and this is my workpiece. In these circumstances, what is going to happen is my abrasive particles are fixed and workpiece is going to create the shearing action in the same location. Assume that it can create in the same location. This is the location it can create. This is the location it can create. This is the location it can create. Okay. So, it is a fixed. That means, here only two bodies are in contact. One is the body 1, another one is, these are the abrasives which are there, is the body 2. That is why it is called a two body abrasion. When the abrasion is taking place between two bodies, it is called two body abrasion. In other case, the three body abrasion means, as I said, this is my workpiece, and I have my polishing pad. Here abrasive particles are randomly oriented, assume that, along with the liquid. My abrasive particles are the additional materials. Apart from this, you have the fixed entities also. So, if the abrasion is taking place between I can say the abrasion is taking place between three bodies, it is called a three body abrasion. When it will take, for example, to understand you, for a single point cutting tool, assume that if you are going to use, so tool is there and the workpiece chip is moving on during the cutting operation. If tool and chip interaction is there on the rake surface, what is happening? It is a chip is a one body and the tool is a another body. So, two body abrasion is taking place. Okay. Assume that whenever because of the cutting fluid action or because of the workpiece nature, as normally tungsten carbide tools will be made up of powder metallurgy technique. So, it will have the powdery effect. At the same time, the workpiece also sometimes generate some powders. So, not only this tool chip will have interaction, but also some particles will take place in this abrasion action because of the cutting fluid action or because of the leaching out of the particles, tungsten carbide particles from the tool. So, if there is a 3 bodies involved, then it is called a 3 body abrasion. So, normally lapping process is a 3 body abrasion because not only the pad and workpiece involved, at the same time abrasive particles which are there also play a major role. At the same time, one has to understand is in a 2 body abrasion, abrasive particles cannot roll or it cannot have its own rotation about its own axis, but in the 3 body abrasion, you can see here, if I can zoom this portion, what will happen? My abrasive particles can rotate about its own axis or it can rotate about its own axes. Okay. So, the freedom is too high for the 3 body abrasion. That means that if my abrasive particle in the 2 body abrasion, my abrasive particles cannot rotate about its own axis. If you see in a 2 body abrasion, it cannot rotate, my abrasive particle is fixed. In a 3 body abrasion, my abrasive particle can rotate about its own axis and can generate the randomness on the surface. Okay. Hope you understood the difference between 2 body abrasion and 3 body abrasion. If the 2 bodies are involved in abrasion process, then it is called a 2 body abrasion. For example, chip tool interface, it is a 2 body abrasion process. If the third body enters into the chip tool interface like particle generation, and these particles have its own axis of rotation, then it calls as a 3 body abrasion. Not only tool chip, but also you have a third particles which can rotate about its own axis during the abrasion action. That is why it is called 3 body abrasion. Since the abrasive particles in lapping process are having the freedom to rotate about its own axis, the dominating abrasion technique here is 3 body abrasion. Lapping process mechanism for the ductile materials. Normally, if you see the ductile materials, whenever you have a ductile material to be finished using the lapping process, it will have the shearing effect. So, that means that if you can see the workpiece, lapping film and lapping plate, this is the workpiece, this is the lapping plate, in between you have abrasives and lapping medium, other things are there. Here, momentary effect grains in the lapping film point through the identity lapping impressions in the chronicle sequence. What is it's going to happen here is, first it will indent and it will shear the surface peaks. Okay. So, this is how the mechanism. Normally the ductile material, if the ductile material is there, what will happen? Abrasives are much harder than the ductile material. So, if the peak is there, it will shear off. If the peak is not there or the surface is there, in that circumstances it will indent first. So, whenever it will indent, what will happen? The deformation will take place. Whenever the deformation takes place, assume that this is abrasive particle, this is the surface, the indent take place, there will be a material will come like this, and this portion can be sheared later. But in the brittle material, what will happen? If there is the interaction between workpiece as well as the tool, what will happen? There will be a cracking action and the chip will be removed. So, this is the difference between the ductile material and brittle material. In the brittle material, the cracking will take place and the chip will be further formed. In other case, in the ductile material, there will be a deformation because of the indentation of the abrasive particle, then there will be a material removal. Then the subsequent material removal takes place in the ductile material. Lapping process characteristics, there are hardly any restrictions with respect to materials and workpiece sizes. You can go for big size to small size, whatever the requirement as per your requirement. The machined surfaces have no directional machining marks because your abrasive particles are randomly oriented and a 3-body abrasion is taking place. That means that your abrasive particles can rotate about its own axis. So, there is no certain direction. Like grinding, if you are going to do the grinding process, what will happen? You will get a straight lines, that is called lay. The predominant surface roughness direction is nothing but the lay. Lays, you will have a straight lines. Okay. In this one, there is no lines of such lines. The lines whatever you are going to form will be very fine, and these are all are randomly oriented. The work pieces are carried out with internal stresses as forces involved are very less. That means that there is no internal stresses in the work piece because the forces involved are very less. At the same time, number of abrasive particles are taking part is very huge number. So, the load is transferred to each and every abrasive particles. So, the load sharing will be done among the abrasive particles. So, there is no stresses developed in the work pieces. During the lapping, machining temperatures are low because your carrier medium, sometimes you can use water, sometimes you can use oil, sometimes you can use the emulsions. These are all act as a coolant as well as lubricant, then these will also act as a flushing agent, and the temperature generation will be very minute because there is a film of oil continuously. Whatever the heat generated, that will be taken care by the fluid film. So, there is no heat or distortion in case of the lapped surface. That means that because of the thermal loads, there won't be any, because of there is no temperature generation. So, there is no heat or distortion in case of lapped workpiece surfaces. Commonly, simple geometries can be lapped, even complex geometries can also be lapped. Okay. High abrasives consumption during the lapping process. The only problem here is the consumption of cutting fluid will be very high. I mean to say abrasive particles with carrier medium, because continuously flowing will be taking place, and this pads, it will go in between the pads and the workpiece, then the finishing action will take place. The lapping materials, normally abrasives that are used in the lapping process, if you see Al2O3, that means alumina, silicon carbide, chromium oxide, boron carbide, diamond, different materials they can use at the same size. At the same time, grain sizes are 5 to 100 microns, 1 to 2 microns of cerium oxide and boron carbide. These are the ranges of the abrasive particles that are uses. These are the ranges of the abrasive sizes of this particular abrasive type can be used in the lapping process. The medium agent material for the lapping process, normally the carrier medium will be a liquid, along with that abrasive particles are mixed, and these are all sent to the finishing region. So, the commonly used are machine oils, rape oil and greases. Silicone oil also people will use, some of the cutting fluids also you can use, and people also uses water also. Technical parameters affecting the lapping process, these are the input parameters, that is the unit pressure, how much pressure you are going to apply, and the grain size of the abrasives, and types of abrasive particles also play a major role, like type, whether it is SiC, Al2O3, diamond, what are the things, that also type also. Concentration of abrasive particles, that means that whether the high number of abrasive particles per unit square area is used or low used, that also play a major role. If the abrasive particle density is very high, that means that number of abrasive particles involving per unit time will be very high. So, material removal rate obviously will be very high, and the lapping speed. So, how speed? If your speed is very high, there are two possibilities. One, the machining rate will be very increased. At the same time, abrasive particle may not get sufficient time to remove the material. These are the two possibilities, and you have to strike the balance between these two as per your requirement. The brittle workpieces are normally you can use the diamond, cubic boron nitride, silicon carbide, aluminum oxide and carborundum. These are the workpiece materials normally people will use for the lapping process. So, ductile workpieces are mild steel, copper, brass comes under the slightly brittle workpieces. So, these are the other workpieces that you can use. Coming to the types of lapping processes, we have varieties of lapping processes. So, the first one is one sided lapping process where you have a tool that is a lap and another is a workpiece, and you can give the random surface and to the finishing and other things. Another one is two sided also you will be used. So, this is a cylindrical workpieces whose flat surface has to be finished. In these circumstances, you will have two laps, that is the lap 1, lap 2. Okay. These are the two laps you can use, and the abrasive particles are placed in between along with the carrier medium, so that the finishing will take place on the both sides. So, the surface lapping is one of the most important lapping process, where the surface lapping in this one normally you will go for finishing of a flat surfaces. The surface lapping is a lapping of even surfaces in a single and mass parts for the generation of high quality surfaces in terms of evenness and the surface roughness. That means that the flatness also you will achieve, at the same time better surface roughness also you will achieve in terms of surface lapping. So, you can see here in this condition, this is the work piece and the lap will be there on this one, and you will apply certain pressure and you can achieve the even flat surface along with the better surface roughness. Or you will see this is a lap plate that is there on the, and you can go for different work pieces also. As I said, it can be, the lap can be at the bottom or at the top. Some of the pictures you may get at the bottom, some of the pictures you may get at the top. So, do not confuse it, because in the surface lapping both looks like flat surfaces only. So, I mean to say, sometimes I will tell that by seeing at the flat surface I can tell that this is a workpiece or something, okay. That can be a lap also, but the function is same. If I consider the bottom one is a lap, the top one will be the workpiece. If I consider the top one as a workpiece, I can say the bottom one is a lap, okay. So, these are the abrasive particles and carrier medium, and this is the workpiece. So, the abrasive particles are free to rotate about its own axis. They can rotate about its own axis, and three body abrasion will take place. Normally, the slurry means it will have abrasive particles plus carrier medium. In the surface lapping, if we can see, this is the weight that is to apply the load, and the carriers normally will have different shapes and ceramic rings. Then the plate will be there, and you are going to put the abrasive particles along with the carrier medium to finish, and the best surface finish that you can achieve is in the nanometers. As you can see here, these are the brittle surfaces which are finished to the mirror surface, and this uses for the very advanced applications. Surface roughness is very good, and on the other side this structure will have some other structures. This may be used for very advanced techniques where the heat may be generated, because of which the heat can be dissipated from the bottom side. For that applications, people will use the lapping process, especially surface lapping. Surface lapping can give you very good surface roughnesses, and you can get the mirror surface roughness, and you can see your face through these mirrors. Next one is the cylindrical lapping. So, see, in the cylindrical lapping you can go for external cylindrical lapping, at the same time external cylindrical lapping of the face lapping. That means that here it is along the axis. This is the axis, along the axis you are going to do the lapping process. Here you can do for the faces. So, that means that previously you have seen If you are going to do the finishing of this one, that is called face lapping, and at the same time you can use for the internal also. In that circumstances, you have to reverse the lap as well as workpiece. If at all you want to go for the cylindrical surface to be finished internally, then your lap will be at the center as a mandrel, and if you at all you want to do the finishing of a external surface, you will have a hollow lap. You can see here workpiece, this is the workpiece to be finished. So, processing liquids are there, at the same time 2 rollers are there, just you put the liquid and you can do the finishing. This is a schematic to show how the cylindrical lapping works in practical. There is another one that is called thread lapping process. In the thread lapping, you can go for the external thread lapping. These are the threads that are generated, and you will have a converse hollow type of structure will be there as a tool, that is nothing but the lap, and you can do. In the internal threads, you will have the workpiece hollow and the pad will be a mandrel type of things, so that you will get the threads to be finished. You can clearly see here, these are the threads or some of the structures that are to be finished by lapping process. Lapping liquid is there already, and these are all done normally by, these are all the external threads that are to be finished. This is external threads, and you will have a converse shape of this type of threads, and you do the polishing fluid, you place the polishing fluid, then do the finishing operation. Then the other variety is profile lapping, spear lapping. Normally you have a hemisphere, spears will be there, for which you will have your tool as a hemispherical structure. So, your workpiece is convex, so your tool will be like concave. Okay. So that you can achieve the better surface finish, and your fluid as well as pad can go to each nook and corner of the surface and do the finishing operation. At the same time, cone lapping, you can also go for the cone lapping, where you can do the finishing operation of this particular cone. And the other variety is the roll lapping, where you can see there is tools are there, and you can use one roll as a workpiece, another one as a tool. This is the workpiece, and this is the slurry that is placed between the 2 rollers, and this is a tool. Tool will be always supporting the abrasive slurries. The abrasive slurry in this case will be supported by the tool, that means that the pad and the finishing will takes place on the workpiece. The main components of the lapping process in this, the first and foremost is the lapping plate. The types of lapping plate is important, as a workpiece can be badly scratched and contaminated with abrasive particles if the plate is too hard. That means that if your lapping plate is too hard, what will happen? It not only generates a surface finish, but also it can create the scratches on the surface, because the load applied will be very high. The abrasive particles roll more than they slide, so the most of the material removal by the stress inducing the micro fracture. Sometimes if the plate is hard, what will happen? The load applied will be very high. For the same load, the workpiece, if it is hard, the density of the plate will be very high, so the self weight also will be very high. For the same load, this hard plates may damage the workpieces, and even they can create micro fractures, and these abrasive particles can also embedded more into the workpieces. That means that if the pad is too hard, for the same load application, what will happen? It will generate more stresses on the workpiece, and micro fractures will take place on the workpiece. At the same time, sometimes there is a chance that the abrasive particles will embed, if and only if the workpiece material is too soft, like aluminum or something. If a hard plate, very fine abrasive particles can impart better surface finish with respect to planetary. That means that whenever you are going to use a very hard plate, that is lab plate, you go for very fine or a super fine abrasive particles so that you can achieve the good surface finish. The lab plate, basically there are varieties of lab plate. Few of the lab plates we will see. Some of the lab plates can be fabricated by cast iron, copper, ceramic and other things. You can see the copper, ceramics are there and cast irons are there. Many things are there in this one. Just for example, I am just showing here. And the first one is cast iron plate. You can see the cast iron plate. So there are varieties of lab plates are there. These are all made up of many type of materials ranging from ductile to brittle and intermediate. So the cast iron, copper and ceramic, these are the varieties of material where the cast iron and copper comes under the ductile regime, as well as the ceramics will come at the brittle. Normally you can see the copper ones you can easily identify, but however the other things we will see in the next one. Even we will see about the cast iron plate, copper plate, what it is functions, how it is going to do the finishing operation and other things. So first we will go with the cast iron plate. The cast iron lab plate has aggressive stock removal rate. That means that it uses for material removal application. It is an excellent primary or roughing plate. That means that whenever you want to go for the lapping in multiple phases, that means that first phase, second phase, third phase. So first phase always will be a rough phase. You can go for the rough phase using the cast iron. It produces the good surface finish on the most material, especially metals and ceramics, typically used for the coarse and medium diamond sizes. That means that this will be very good if at all you are going to use for the material removal. At the same time, these are all good for metals and ceramics, where you require more and more the loads to remove the materials. The next one is the copper plate. As you can see the copper color of this plate as such. The copper plate is most widely used in universal composite lab plate for excellent primary and finishing operation. This can be used for primary, that is for material removal applications also, as well as for the fine surface finish applications also. Whereas you have seen in the previous slide, cast iron will be used mostly for material removal or the stock removal applications. That means that initial stages you can use. This copper you can use for initial stages as well as for the final stages also, or you can go for combining the primary as well as finishing applications also. That means that one go you can go for the coarse as well as fine. You can club both things also. Hope you understood. If you are not understood, what I mean to say is that copper plate can be used for the coarse applications also. That means that stock removal applications as well as fine applications. This is subjected to how much load you are applying, how much abrasive particles you are putting, what is the size of the abrasive particle will also play a major role. If at all I want to go for material removal, the initial stage with the copper plate, you just put high amount of abrasive particles with core sizes, that means the big sizes. So it will go. Second, what will happen? You just put the slurry fine, but without changing your lap, that means the copper plate, it can also serve for the purpose of finishing applications also. So in the second phase, fine abrasive particles with less density, you can go for finishing, but you are not changing the plate. It is suitable for metals, ceramic, glasses, carbon, and it is minimizes the fracture and chipping tendencies when the lapping. So it will reduces the fractures. In the cast iron, what will happen? If the low or in the ceramics are if you are going for hard work, hard plates, what is going to happen is it will apply a lot of load, fracture will take place. But copper is a soft material, so it won't create any fracture. It is preferred for lapping medium to fine diamond sizes. That means that it can normally applied for medium surface roughnesses to the very fine surface roughness applications. And the ceramic plate is the third variety. Ceramic plates are normally used for the very sensitive workpieces. The ceramic plates is generally used for lap or polished ceramic parts. Normally, ceramic parts are very sensitive. That's why I use the sensitive word. Ceramics are prone to have the fracture or prone to have the cracks. That's why these are sensitive. Other strain sensitive materials and used for applications where metallic type of contamination cannot be tolerated. So that means that if you are going to use the copper, what will happen? Copper itself is a soft, so there is a chance of chipping from the copper plate will takes place, and this will contaminate the fluid, that is the carrier medium, as well as contaminate the workpieces also. So these are very flexible and hence can be used with coarse to fine diamond. These ceramic plates also, like copper plates, you can use for the coarse application, that is the material removal application, as well as for the fine applications. This plate encourages the moderate stock removal. That means that this will be mostly used for the moderate material removal rate conditions. So the lap plates, the other variety is tin or lead type of plates, where the tin or lead plates is mostly widely used for finishing lap plate. That means that these are exclusively used for finishing application, that means the final applications, and typically used for very fine diamonds and minimizes the fracturing, and these plates are aimed to obtaining the fine stock removal. That means that previously you have seen the cast iron, you have seen the ceramic, you have seen the copper. These are all three varieties will be used for coarse application, that means that material removal applications, as well as you can go for medium application, but the final finishing application you can go for these type of plates. Okay. So you can see the diamond particles grade. So iron you can go for 30 micron diamond particles, and you can see the tin. This tin normally uses for super finishing application, where the particle size of the abrasives that are going to use is 1 micron or something. Okay. So from this picture, the iron, copper and other ceramics are used for the coarse and medium applications, but the tin will be used for the fine application. That means that if at all I want to go for multiple processes or the multiple times I want to finish, first I will take the cast iron, I will do the rough finishing operation, then followed by I will use a copper plate, I will go for the medium finishing, then I will go for a tin plate along with the fine abrasive particles and go for the final finishing application. So in this case, I am going for 3 rounds of finishing application, first with the cast iron, second with the copper, third with the tin plates. Okay. The abrasive particles, the lapping process, normally diamond, these are suited for the tungsten carbide and other very hard materials. Cubic boron nitride, these are the suited for the ferrous workpiece materials. So if at all you want to finish the iron based, then you can go for the cubic boron nitride. Carbide suited for USLR applications for special lapping operations. Aluminum oxide is one of the commonly used along with the silicon carbide. This will be used for high tensile strength materials and hardened gears, balls and other things. Silicon carbide is suited for the rough lapping process. That means that whenever I want to go for the stock removal, you can go for the silicon carbide. Garnet is nothing but it looks like a sand, which will be used basically in abrasive jet machining or abrasive water jet machining. These conditions it will be used. It is used for suited for cast iron, brass, which are the slightly brittle materials. You can use the garnet. Lapping process, abrasive slurries. If you see, the purpose of any carrier medium is to carry abrasive particles and to position them to the workpiece efficiently. The carrier medium is like oil, or if you are going to use the grease or something, these are all going to use for carrying the abrasive particles. Along with that, it has to position these abrasive particles at equal locations. The carrier medium also lubricates, because it will assume that I am going to use oil, this will try to lubricate the workpiece surface. Okay. So, and ensures the carries away the abraded workpiece material. That means that you are putting the abrasive particles along with the carrier medium will carry these abrasive particles and uniformly distributes. At the same time, whenever there is a interaction between workpiece and abrasive particle, in that circumstances there will be a chips are produced. These chips are also carried away by the carrier medium. And these abrasive slurries are mainly divided into three categories. One is the water soluble slurries, oil based slurries, and oil water emulsion based slurries. These are the three varieties. Lapping process in the abrasive slurries, if you see here, oil soluble slurry, oil water emulsion, and water soluble polymer slurry, and other resins also you can use, water also you can use. You can see these are the white ones are water molecules and the black ones are oil. Okay. You can go for varieties of these things. Okay. Only you can go for oil type of things, or you can go for oil water emulsion, or at the same time you also use some of the polymer particles also. Water based vehicles are commonly used for the lapping, and water soluble slurries are preferred for avoid health hazards. Basically, these slurries, once you uses, you have to go and dump into the some sites, whether it is a water body or a soil body. It will create lot of problem to the environmental effect. For that purpose, if you go for water based slurries, there is no contamination problem. Oil has tendency to penetrate into the pores of some of the materials. Materials disposes of oils and now considered as hazardous waste. Basically, these oil based cutting fluids, which you have seen in the previous classes, will have lot of adverse effects. Similarly, this type of oil along with abrasives, it will be contaminated like anything. This, if at all you want to go and dump into the river will contaminate and causes the soil and causes the water pollution. Basically, if you are going to dump into the digged well that is on the soil, so it is causes the soil pollution. Oil water emulsions has a shorter shelf life than the oil emulsions, and the concentration of the abrasives affects the stock removal. That normally, if you are going to have abrasives, high amount of abrasives, what will happen? The material removal rate will be very high. If your stock removal is main criteria, then you go for coarser particles as well as high density. That means that number of particles per unit area will be very high. If at all you want to go for finishing, you use low and superfine abrasive particles. So, plate conditioning is another one. Normally, it is important when flatness or the parallelism is crucial. Plate conditioning is a process by which the lapping plate of the surface is machined is maintain the flatness of the lap plate, and preconditioning of lap plate surface is being done. Normally, whenever you have there is a change in the lap plate or something, the shape is not proper, you have to condition it. That for that purpose, you can see, assume that my lap plate is like this. So, I can use a lap wheel and I can do it very flat. If it is like this, assume that I have a plate like this. I want to make it flat like this. So, I will use the conditioning plate. I can remove this portion and I can make like a flat surface. So, you will see the conditioning in the next slide. Initial plate shape is like this, and if you are using a conditioning plate, and you can make it very flat, so that you can achieve very flat, and you can use this particular flat surface to the workpieces. In the other condition, this is the initial condition, you use the conditioning lap and you can make. If your position is here, what will happen? In this position, it is not coming, so you are getting some profile. These are all used for profile lapping purpose. Okay. If you are having this type of surface, and for now you want to convert here like this, you can go for, you can change the location of your conditioning ring and you can get flat surface. This can be done in 2 steps also, like this is the step 1 where you are converting 1 to 2, and another one is this 2, if you are taking, you can convert it to 3. That means that you are going to fit flat. This you can use for surface lapping application. Okay. So, this is what the conditioning of the plate, that means the lap plate. If the lap plate is not properly placed or lap plate is not proper, the surface is not proper, you will have to take additional help of certain rings, that is conditioning plates are available. You use that one to make it perfectly flat or as per your requirement of the profiles. So, lapping effect, scratches on workpieces and abrasive damage due to particle breakage and forces developed affect the properties of the workpiece surfaces. These are some of the effects. You can say that scratches also, whenever you are going for the big workpieces with hard plates, normally scratches will take place, and abrasive damage, whenever you are going to use the ceramic plates, abrasive particles are there. Because of this interaction of this ceramic plate, that means that lap plate with respect to ceramic particles, both are the brittle. So, there will be a abrasive damage will be taking place, and forces developed affect the properties of the, that means that if you are going to have the ceramic plate, the forces will be very high for the same load application. So, there will be a workpiece damage if the workpiece is brittle. The materials, silicon carbide, alumina, boron carbide, diamond, these are the hardness values, densities. Normally, these are the structures. So, these are the abrasive particles commonly used for the finishing using the lapping process. And advantages of this lapping, high accuracy surface finish, you can achieve the nano surface roughnesses, nanometers you can achieve, and good quality. There is no thermal damage because temperature generation is too low, and the repeatability because your pad is perfectly flat. At the same time, you are going to use the concentration of abrasives, everything if you are maintaining constant. So, you are going to get the repeatable surface roughness subjected to your workpiece initial surface roughness also the same. Required tolerance achieves, you can achieve very fine tolerances, no warping of the components, there is no damage to the, and no heat generation. As I said, this liquid film will be there between the two. Assume that I have a workpiece, I have a tool, in between abrasives are there, at the same time your carrier medium is there. So, carrier medium will take away the heat. So, there is no thermal distortions or any thermal oriented damages. Applications of lapping process, you can use for variety of engines as well as ceramics and rubber, stainless steel, tungsten, plastics and silicon wafers, bronze, carbon rings, and these are the many applications for many sectors you can use for many of the components, and lapping process is one of the big businesses in the fine finishing applications. Okay. I mean to say certain complex products for high end applications, that particular company will have the lapping process. These are the valves manufacturing is one of the applications, automotive industries, pump manufacturing, electronic industries, where you can make, you can see the disc. These are normally developed by the lapping. The advanced versions of lapping, there is called CMPs, that is called chemomechanical planarization or chemomechanical polishing. So, people will use for that also. Air compression industries, these are all to be properly finished, so that you can achieve better surface finish on the surfaces, so that there won't be much losses, or if the roughness is very high, there will be losses will be very high. The before and finishing of the lapping, you can see the surface is not proper and you can achieve the good surface finish. You can see here also, in the previous slide also you have seen this particular thing. So, surface finish will be very high and your applications are tremendous in numerous manufacturing industries, and you can see the various other applications. As I see that these are the mirrors that are subjected in high end applications where heat is also generated, for which there is a structures are given from which this heat will be dissipated. Summary of this particular class. So, we have seen various varieties of lapping processes like surface lapping, profile lapping, thread lapping, cylindrical lapping. In the cylindrical lapping, we have seen external, internal, thread lapping, external threads and internal threads, many more we have seen. Hemispherical, in the form lapping, you have a hemispherical as concave, convex, so many we have seen. And in particular, overview of this class summary, we have seen the lapping process, which is introduction to lapping, terminologies of lapping. We have seen the various methods of abrasion, that is 2-body abrasion, 3-body abrasion, when there is a no rolling effect of the abrasive particle about its own axis, it is called 2-body. If the abrasive particles has its own freedom to roll about its own axis along with the 2 bodies that are involved in abrasion, then it is called a 3-body abrasion. And various types of lapping, like we have seen in the previous slide also. To overview, I have shown you the cylindrical lapping, thread lapping, form lapping, surface lapping and other things. Main components, lap plate is there, workpiece is there, carrier medium and abrasive particles. These are the main components of the lapping process. Advantages of the lapping process, you can get very fine surfaces, nano surfaces you can get. At the same time, you are going to get very fine surface with no thermal distortions, because there is a fluid film which will prevent it. If there is a slight heat generation, it will take away, and the debris it will take away, everything it will take care. So, it is the very good process from the surface finish point of view. And applications, it can have varieties of applications like valves, pumps, at the same time mirrors and other things. Okay. Thank you for your kind attention for this class.